Okay, homework 14 is on trigonometric equations. So we've got a bunch of different types. I'm going to go through and do a handful of examples. So I'm going to start this first set. These are the more basic. These are ones that don't involve factoring at all. They treat tangent or cosine or sine kind of like it's a first degree term. So let's do one of the basic ones. We'll just start with number one. So this one you want to get tangent theta, sine theta, or cosine theta completely by itself. Treat it basically like it's an X or a Y or something like that. So here, the one and only step we need to do to set it up is to divide both sides by 3. So when we divide the left-hand side by 3, and then dividing the right-hand side by 3, -3 over +3 is a -1. So at this point, you guys have enough practice with the unit circle, enough knowledge to know where tangent is going to end up being a -1. So tangent is a -1. Negative is in either the second quadrant or the fourth quadrant. And remember, it ends up being -1 at those pi/4 family members. Because pi/4, it's a positive one, which means if we work our way around, so the second quadrant would be 3 pi/4, and then the fourth quadrant would be 7 pi/4. All right, so that's the more basic version. Let's spend some time doing the ones where some factoring is involved. So anytime there's a quadratic or things you need to simplify, there's some factoring involved. So many of them have just a single, we can call it a variable, only cosine, only sine, only tangent. When you get into the more complicated ones, there's a mix, and that's when it should be one where you have to use one of your properties. So let's start with number 7. Factoring means you start with everything on one side of the equation, which we're good with here, and then you use really any of your normal factoring techniques. So think of this as like a 2x squared minus x. If you were given that, you would look first for a GCF, and we do find one. Each of these terms has a cosine of theta in common. So you factor out one copy of cosine. This is 2, and then another factor minus, don't forget to leave a 1 behind. If it seems like something completely divides out, do make sure that you're leaving a 1 behind. So we have 2 different factors here. We want to take each one of those factors and set them equal to 0. And we'll get 2 different sets of angles. So the first one is ready to go. So cosine of theta, remember that's the x-coordinate. So where the x-coordinate would be 0, think of that. That's the top of the circle and the bottom of the circle. That's where the x-coordinate would be 0. The top of the circle in degrees is 90. Bottom of the circle is 270. So you've got those. This one, we can start by adding 1 to both sides of the equation, and then we would divide both sides by 2. So cosine equals 1/2. So think that through. So cosine equals 1/2. You should recognize the first quadrant value, which is 60. And then remember, cosine is also positive on the right-hand side of the graph, which would be quadrant 4 as well. All right, so we recognize the 60, hopefully, with all of our unit circle knowledge at this point. And then we also have one that's positive in the fourth quadrant. So if we use 60 as our reference angle, the one that appears in the fourth quadrant is 300 degrees. All right, so we have all of our options here. So these are all of the degree values that are a solution to this equation. All right, let's look at a couple on the next page. Let's do number 11. This is slightly more traditional factoring, I guess you could say. I mentioned make sure that everything starts on one side of the equation. So the very first thing that we need to do is subtract the 5 from both sides. So 7 minus 5. And then this is more traditional factoring. There's no GCF, so this is just, if it were y or an x, it'd be y times y or x times x. So here we start with sine times sine. And then the numerical part, like this missing piece, works exactly the way it does with normal factoring. So these are supposed to multiply to 2, and our middle term is supposed to add up to 3. So that would be plus 2 plus 1. All right, so each one of these pieces, you can take this piece and set it to 0. You can take this piece and set it to 0. So for the first one, we would start by subtracting the 2. So we end up with sine theta equals -2. And so this, we want a y value of -2, which is 2 units down. So that's actually below any part that the unit circle ever hits. Sine only goes from -1 to +1, so this is outside of our range of values. So we have no solution for this first one. Second one, we subtract 1 from both sides. And this is the very bottom of the unit circle because you can go 1 unit down, you just cannot go 2 units down. So very bottom of the unit circle in degrees would be 270 degrees. So we just have one solution for that one. I wanted to choose one as well where you end up having to use some properties. So let's do 15. 15, one of the clues is that you have a mix of variables. If you have a mix of variables, you're definitely going to have to use some sort of property, try to rearrange them, get them all in terms of just one, either cosine or sine or tangent. Even one of the other 3 is available in weird cases. So sine squared, this is like the Pythagorean identity. Remember, we can write sine squared as 1 minus cosine squared, just slightly rearranging that Pythagorean identity. And so this is now a quadratic. We want to solve that quadratic by getting everything on one side. And let's get everything on this side so that the cosine squared is positive. So add cosine squared over here. It will join the cosine that's already here. And then when I subtract 1, 1 minus 1 is 0. So there are no plain constants on either side. Quadratic, we go to factor it. This one you can take out a GCF, very similar to the second problem I did. So factor out a cosine. After I factor it out, I'm left with cosine plus 1, and I can take each of those and set them equal to 0. So cosine equals 0, I already saw this one on the previous page. That happens at 90 and at 270. And then when I take cosine plus 1 and set that equal to 0, I would subtract the 1 from both sides. So if I want my x-coordinate to be -1, that's 1 unit to the left. So that is the furthest left edge, and that would be 180 degrees. All right, so let's put all 3 of them together in one list.